ओम नमः शिवाय। जय गणेश, जय लक्ष्मी जी, जय श्री राम सीताराम। हर हर गंगे, हर हर महादेव, जय भोले शंकर, जय बजरंगबली, जय हनुमान। I am again back to the my lecture series, computer lecture series, learning computer with seeing the natural sights of Indian village. So you see these beautiful natural sights of Indian village, and you learn computer by seeing these natural sights. Today I would like to talk about the operating system of a computer. So let's start the discussion about computer system. Uh, an operating system is an integrated set of programs that controls the resources, that is central processing unit, memory, IO devices, etc. of a computer system, and provides its user with an interface or a virtual machine that is easier to use than the bare machine. According to the definition, the primary objectives of an operating system is to make a computer system easier to use. The computer system consists of one or more processor, main memory, and many types of input-output devices such as tapes, disks, terminals, network interface. Writing programs for using these hardware resources correctly and effectively is an extremely difficult job requiring in-depth knowledge of functioning of these resources. Hence, to make computer systems usable by a large number of users, it became clear several years ago that computer system needs some mechanism to shield programmers and other users from the complexity of hardware resources. Researchers gradually evolved a solution to handle this problem by putting a layer of software on top of the bare hardware. This layer of software manages all hardware resources of the system and presents the user with an interface or virtual machine which is easier, safer, and efficient to program and use. It is called the operating system. जय श्री राम, जय सीताराम, जय बजरंगबली। ओम नमः शिवाय, ओम नमः शिवाय, ओम नमः शिवाय। The second point, the second work a operating system do is that it manages the resources of a computer system. This involves performing such tasks as keeping track of who is using what resources, granting resource requests, accounting for resource usage, and mediating conflicting requests from different programs and users. Efficient and fair sharing of system resource among users and or programmers is a key goal of all operating system. Now the main function of an operating system. First point is process management. And a process is a program in execution. During execution, a process needs certain resources such as CPU time, memory spaces, files, and input-output devices. A particular instance of time, a computer system normally consists of a collection of processes. Process management module takes care of creating and deletion of processes, shielding of system resources to different processes, requesting them, and providing mechanism for synchronization and communication among processes. The second is memory management. To execute a program, it must be loaded in a main memory together with the data it accesses to improve central processing unit utilization and to provide better response time to its users. A computer system normally keeps several programs in main memory. Memory management module takes care of allocation and deallocation of memory space to programs in need of this resource. Now the third point is file management. All computer systems store, retrieve and share information. Normally a computer stores such information in units. Information in units called files. Process read information from files and create new files for storing new data. Next is security. Computer systems Computer system often store large amount of information, some of which are highly sensitive and valuable to their user. User can trust a computer system and rely on it only if its various resources and information stored in it are protected against destruction and unauthorized access. Security module protect the resources and information of a computer system against destruction and unauthorized access. It also ensures that when the system executes several disjoint processes simultaneously, one process does not interfere with others or with the operating system itself. The next point is device management. Device management. Now let's make a discussion about device management. Normally a computer system consists of several input-output devices such as terminal, printer, disk and tape. The device management module of an operating system controls all input-output devices. It keeps track of input-output requests from processes, issue commands to input-output devices and ensures correct data transmission to and from the input-output devices. It also provides a simple way and easy to use interface between the devices and the rest of the system. The next point is command interpretation. For using various system resources, a user communicates with the operating system via a set of commands provided by it. The operating system also provides a simple language known as command language, abbreviated as C, capital CL, or job control language, abbreviated as capital JCL, using which a user can put several commands together from the command set to describe the resource requirements of a job. Command interpretation module interprets user commands and directs system resources to process the commands. With this mode of interaction with a system, users are not much concerned about hardware details of the system. Operating system also performs few other functions such as accounting of system resource usage by all users or processes, maintenance of log of the system usage by all users, and maintenance of internal time clock. Now let's talk about the measuring system performance, that is how system is performed and its benefit and its characteristics. We usually measure efficiency of an operating system and overall performance of a computer system in terms of following parameters or characteristics. Turnaround time. From the point of view of an individual user, an important criteria is how long it takes a system to complete a job submitted by the users. Turnaround time is the interval between the time of submission of a job to the system for processing and the time of completion of the job. Although higher throughput is desirable from the point of view of all overall system performance, individual users are more interested in better turnaround time for their job. Next point is throughput. Throughput is the amount of work that a system is able to do per unit time. We measure it as the number of job processes completed by the system per unit time. For example, if a system is able to complete n process in t second, its throughput is n by t process per second during that interval. And throughput is measured normally in processes per hour. Note that throughput of a system does not depend on its job processing efficiency, but also on the nature of job processed. For long process, throughput of a system may be one process per hour, whereas for short processes it may take 100 or 110 processes per hour for the same system. The third point about measuring system performance is that is response time. Turnaround time is not a suitable measure for interactive system because in such a system a process can produce some output early during its execution and can continue executing while previous results are being output to the user. Hence, another measure used in case of interactive system is response time. It is the interval between the time of submission of a job to the system for processing and the time of first response from the system for the job. So these are the points regarding measuring system performance. Now let's know about the process management. A process, also called job, is a program in execution. The main objective of a process management module of an operating system is to manage the process submitted to a system in a manner to minimize idle time of processors, that is central processing unit, input output processor, etc. of the system. We will learn about some of the mechanisms that modern operating systems use to achieve this objective. We also see how these mechanisms have evolved gradually from the early days of computers. So the process management in early system as follows. A program first point, a program first wrote a program on paper. Second, the program or a data entry operator then punched the program and its data on cards or a paper tape. The third is the programmer then submitted the deck of cards or the paper tape containing the program and data at the reception counter of a computer center. The fourth point, the next point, an operator then loaded the card check deck or paper tape manually into the system from card reader or paper tape reader. The operator also loaded any other software resource such as language compiler or carried out required setting of hardware devices for execution of the job. Before loading the job, the operator used front panel switches of the system to clear any data remaining in main memory from the previous job. The operator then carried out required setting of the appropriate switches in the front panel to run the job. Finally, the operator printed and submitted the result of execution of the job at the reception counter for the programmer to collect it later. Every job went through the same processes. The method was known as manual loading mechanism because the operator loaded the job one after another in the system manually. In this method, job-to-job transition was not automatic, hence a computer remained idle while an operator loaded and unloaded jobs and prepared the system for a new job. This caused enormous wastage of valuable computer time. To reduce this idle time, researchers later devised a mechanism for automatic job-to-job transition called batch processing. Batch processing ensured that after completing execution of a job, the system transferred control back to the operating system automatically. The operating system then performed housekeeping jobs such as clearing any data remaining in memory from previous job which were needed to load and run the next job. Hence, in a batch processing system, the process of executing jobs was follows like this. The first, programmers prepare their programs and data on decks of cards or paper tapes and submitted them at the reception counter of a computer center. An operator collected all the submitted programs periodically, batched them together, and then loaded them all at one time into input device of the system. The operator then gave a command to the system to start executing the batch jobs. The system then loaded the job automatically from the input device and executed them one by one without any operator intervention. That is, the system read the first job from the input device, executed it. And the last one is that after the system completed execution of all jobs in the submitted batch, the operator separated and kept the period output of each job at the reception counter for programmers to collect them later. So the batch processing mechanism helped in reducing idle time of a computer system because job-to-job transition did not require any operator intervention. Another major time saving made possible by batch processing was reduction in setup time by operator by batching of similar job together. For example, by batching together all Fortran compilation jobs received, the system need to load Fortran compiler once only for processing all the jobs. The obvious question is how a computer separates one job from another from a batch of jobs for automatic job-to-job transition. How does the system know which compiler or what hardware devices job needs for execution? when there is no operator intervention. To facilitate all these, researchers introduce the concept of control statement or job control language, JCL, abbreviated as JCL, along with the concept of batch processing. Operating system use control systems to identify a new job and to determine the resources needed by it during its execution. User write control statement in user write control statement in language known as job control language, that is JCL. Hence, each job has beside its program and data a set of instructions called JCL instruction, introducing the operating system on identity and requirements of the job. JCL statement specify things such as name of a job, its username with account number, its hardware and software resource requirement, that is input output devices, language processor, software libraries, etc. during its processing. Notice that a control card uses a special character or a pattern in pre-decided columns of the card to distinguish itself from a data card or a program card. Several systems use $sign characters in the first column or on each control card, while IBM's JCL use slash marks in the first two columns. Other systems use some other characters or codes. With this, I would like to end this lecture at this point. So, let talk, let tell. जय श्री राम, सीताराम, जय बजरंग बली, जय बजरंग बली, जय हनुमान जी की जय हनुमान. ओम नमः शिवाय, ओम नमः शिवाय, ओम नमः शिवाय.